The first speaker will be David Deng, and he will talk about extracting chemical information with documents from desktop to enterprise. David?
Thank you. Good afternoon, everyone. My name is David Deng. I'm an application scientist based in the Boston office. So today I'm going to talk about extracting chemical information from documents. Actually, we had a European UGM back in May, and I did a similar presentation. I was a little carried away, and I was talking for 30 minutes. So before this meeting, our marketing director, Alex Allardyce, sent me an email saying, David, I know you like presenting, but we have a very tight schedule. This time, I can only give you 15 minutes. And Daniel and I were just like, I said, Alex, I have a lot of features, a lot of stories to cover. I can't cram this into 15 minutes. But he said, I know, but we have a lot of good presentations from users, so I can only give you 15 minutes, 20 tops. So just focus on the new features. So today, I'm going to talk about the new improvement in naming and how we expanded and now evolved into a full text mining suite to extract chemical information. So a little background information. What is naming? Naming is a reliable way to convert structures to names and name to structure. And it's actually one module that's available in almost all ChemAxon products. You can run it from Marvin, from Instant JChem, JChem for Office, or you can run it from command line. You can also use our API and embed it in your product. But it's a little inaccurate to call it naming because it can convert many other different kind of chemical information to structure. And we expand this technology, and now naming has become the backbone of our text mining suite. So the basic concept of naming is very simple. We can convert from structure to name and name to structure. So for example, if you have a structure like aspirin, you can use naming to convert to the IUPAC name or the common name. And since 6.0, you can also convert from structure to case number. You can also do the reverse. You can convert from different type of chemical name back to structure. And in fact, we also support a non-standard chemical names and trait names. And again, case number. And since 6.0, we also have Chinese name to structure conversion. So if you have a Chinese name, you can also convert back to structure. So naming we have this tool for a very long time. Now it reaches maturity, but we're still constantly making improvements. So for example, this name, it looks like a correct name, but it actually has a lot of non-standard feature in it. For example, these N1, N4, and this fragment name is actually not standard. Now in 6.1, we can overlook these inconsistencies and still generate the correct name. And also, in the 6.2 version, which will come out later this year, we also support more complex chemical names. So for example, in this structure, you have dispiral and fused ring. This type of chemical name can also be converted to structure. Well, but we also deal with other kind of chemical information. Other than chemical names, you have smells, INCHI, corporate compound IDs, sometimes uncommon common names, and sometimes names in other languages. And how can we convert these chemical information to structure? Well, you probably already know this. You can actually have a customer dictionary on your computer. So what to do, once you install the ChemAxon software, you can add a smiles file and in your ChemAxon directory. And the format of this file is very simple. You have the smiles of the structures and it corresponding to any type of text string. It doesn't have to be in English. It doesn't have to be alphanumeric. It really can be anything. So here is a demo how to use custom dictionary. So first I want to show my dictionary. It's under C drive, user David, ChemAxon. So as you can see, I have the smiles of 5 drug structure and corporate ID ChemAxon 0001 to 5. And I also have aspirin structure and the aspirin name in Japanese and Korean. Here, you can also choose to ignore certain text string because, for example, ATP, it could mean adenosine triphosphate or association of tennis professional. Once you have this custom dictionary, now you can, for example, in Marvin, when you do import from name, you can enter the corporate ID and it will convert to structure. And you can also try with naming other languages. So for example, let's try Japanese name. Let me first fire up my Japanese input application. And I will type in aspirin in Japanese, which is aspirin. And you can also convert other language to structure. And I'm pretty sure this is the first time that anyone typed Japanese in a ChemAxon presentation. And since 6.0, not only you can use your local custom dictionary, you can also call this using web service. This has many advantages. For example, if you're a big corporation and you have a dictionary of corporate ID, before every user, their computer had to have the same dictionary, and that makes the management, very difficult. But if you can call the web service, you can put the dictionary in a centralized server and make the management much easier. So here is another demo video. So you really can use any type of web service. And here I use the Cactus web service set up by NIH. And I'm going to try to convert this fixed ID, which is type of chemical information, to its structure. So if I simply do import name and copy this fixed ID into it and do import, we cannot convert it because we don't support this type of chemical information yet. So now let's use web service to help us. Simply go to preference and enter save load. Here is a text box that you can simply copy and paste this URL into. And now let's try to import this fixed ID again. As you can see, now you can convert this fixed ID to a structure through web service. So that's how you can convert name to structure, structure to name. But usually we don't just deal with one chemical name at a time. In many occasions, they're hidden in documents. So how can we extract these chemical information from documents? That's why we developed Documentum structure to help you extract chemical information from documents. So if you have a document, for example, this journal PDF, there's a lot of chemical information in it. There is chemical name, corresponds to a structure. And there's also the chemical structure image. So when you have documented structure, you can simply open this PDF and it will look for any type of chemical information. It could be a chemical name, and we use our name to structure to convert to structure. If it's an image, before 6.1, we support author. You just need to install author on your computer, and documented structure will call author to convert this image to structure. Since 6.1, which was released 2 days ago, we also support Collide and Imago. So if you have any of these optical recognition software installed, documented structure will automatically call them and convert the image to structure. Well, some people may say a journal article is easy because it's actually a text PDF. What about chemical patterns? It's not a full text PDF. Well, if you have a non-text PDF, documented structure will first use OCR and convert it to full text. Of course, the OCR technology is not perfect, so it could make many mistakes. And we do have a correction algorithm that will look for these common mistakes and correct them to the accurate name before we do the structure conversion. So, for example, here, this should be methyl, and it's, after OCR, it's R and N, YL is Y1, oxygen is 0. All these will be corrected before we do the conversion. Here's another example, sometimes that this is a non-Latin alphabet. All these mistakes will be identified and corrected. And I mentioned we also can convert Chinese name to structure. And right now, we're also developing a correction algorithm to correct the Chinese OCR mistakes before we convert these names to structure. And if you think English OCR is messy, you should really look at the result from Chinese OCR. Sometimes it can be funny. And if you're wondering what this Chinese name is, it actually means right now we're developing a correction algorithm for Chinese OCR. So here is the demo for documented structure. We start from a difficult example. This is a pattern, chemical pattern PDF. So here show you can't really highlight any text or copy. Well, there are many ways to run documented structure. One way is to simply import this PDF into Instant JChem. In Instant JChem, as you can see, when you import, you can choose document, and it supports all different types of document. Well, I'm not going to actually import it because it may take some time, but here's the result. It will convert all the chemical information found from this document into structure. So for example, here is a chemical name, and also list what type of chemical information, whether it's a common name, systematic name, structure image. And here is a new feature in 6.0. Not only show you the name, but also give you the context, which means it gives you the text before the name and after, which is a very nice feature if you want to go back and look for that information. So for example, I know this structure is in that document somewhere, but I don't know where it is. And there is also no image on that page. I can simply do a structure search in Instant JChem. And Instant JChem will tell me this structure appeared 3 times, twice on page 28. This is the name associated with this structure. The first time is after example 52. The second time, there is a numeric marker 0233. Now I can simply go back to the document and jump to page 28. As you can see here, it says example 52, and this is the chemical name. That's the first time. The second time, here is the numeric marker 0233. Again, this is not a text PDF, so you cannot do text search. But with documented structure, you can not only do text search, You can also combine it with structured search. So for example, I can modify my query and do a substructure search and say it has to appear on page 28. And these are the different structure with that query on page 28. So that was how to extract chemical information from one document. But usually, you're not just dealing with a few documents. For a big corporation, usually there's hundreds of thousands of internal documents, if not millions. How can you extract chemical information from all these documents? That's why we expand document structure technology. Now we have document to database, JChem for SharePoint, and chemicalize.org. My colleague Attila did a nice presentation yesterday about JChem for SharePoint, so I'm not going to say anything about it. Chemicalize.org is a free web service that you can extract chemical information from web pages and document. You can probably find the old UGM video. We also have a poster there if you're interested. I do want to spend some time and talk about document to database. What is document to database? A lot of corporations are using document repository system. For example, Documentum to manage their internal document. It could be a PowerPoint slides. It could be Word document. It could be a journal articles, chemical patent, etc. Document to database will run document to structure technology on all these documents and collect all the chemical information and push the result to database. Not only you have all the chemical information, you also know where these information are from in the document, and you can also search within these documents. Here is a video for document to database. This, we actually just set up this recently because it used to be very difficult to demo document to database. Everything's on the server side, but now we have a demo. Let's go to d2db.chemaxon.com. We have two demo sets. One is from USPTO chemical patent. We used 1 week of the patent XML published by USPTO. So let's try this patent site. So first, we go to this search interface. When you click Open Sketcher, Marvin for JavaScript pop up, and you can sketch a structure query. You can also choose not only to do substructure, you can also do full structure, exact match, similarity. You can also set different criteria, like molecular weight range, advanced structure features. When we extract information, we didn't just extract chemical information. We also get the titles, assignees, patent IDs, etc. from these XML. And as you type in, for example, assignees, all the available results are showing. So I can choose one. Here are the structures extracted from these patents. If you click on the structure, it displayed not only the structure, molecular weight, it also shows you the context, and it shows you a link of that patent. If you click on that, here is what we call an annotated document. All the chemical information on this has been highlighted, and if you move your mouse over, it displays the structure next to it. So, for example, here are all the chemical information, the chemical names, and this structure will be displayed. Sometimes you do see document to database missing name, and in most cases, I wouldn't say in all cases, but in most cases, there is something wrong with the name. Sometimes there could be a rare OCR error. Sometimes there could be ambiguous name. And if it's ambiguous, we will not convert it to a structure. So that was a short demo of document to database. after my presentation, there's actually two other presentations, one from DuPont, one from Takeda, talking about documented database. So you'll get a better understanding. And here, the last demo I want to show is actually not released in 6.1, but little preview for 6.2. This is the new feature we call document annotation. So if you have a document, for example, again, this journal article, and there's chemical names next to it, with document annotation, you can generate a HTML file, look just like the PDF. But the chemical information are highlighted, and if you move your mouse over, the structure is displayed next to it. So, and we call this is an annotated PDF. You can do the same with, for example, patent XML. This is one of the US patent, USPTO published patent XML. Again, you can generate a HTML file that you actually saw this in the last demo video. All the chemical information highlighted, and when you move your mouse over, the structure will display the next. And I mentioned we can convert Chinese name to structure. So if you have a Chinese document, this is an actual Chinese patent XML. Again, you can generate a HTML. All the Chinese names are highlighted, and if you move your mouse over, the structure will be displayed next to it. So that's all I want to show you. In summary, the new naming has become faster and more accurate, provide a more reliable conversion. It's also now multilingual because it speaks both English and Chinese. It's very versatile. Like I said, you can run it in almost all our products, in Marvin, in JChem for Excel, instant JChem on command line, or using our API. It's also really the backbone of our text mining suite. As you can see, now we have documented structure, documented database, JChem for Excel, etc. I showed you some of the features that will be available in 6.2, but there's actually more. For example, we're always thinking about expanding our support to other languages. And after collecting some feedback, it seems like, for example, Japanese may be equally important to Chinese. And in the next version, documented structure will support multi-core, so you can run parallel computing, which makes the process even faster. And right now, documented database support Documentum. We also want to expand the support to other platforms, for example, OpenText or Google Drive. That's all I want to show you today. I really want to thank Daniel. Even though I did the presentation, but he did all the hard work. So he is the heart and soul, the brain and the arm of naming. And I also like to thank our Argentina team who they built the demo site for documented database. And also I put my name on there because I'm involved in the Chinese name to structure development. Thank you.
Thank you, David.
So this is really fantastic.
Thank you.
I was wondering, for a long time now, you know how Google Desktop used to be around?
Mm-hmm.
And you can go and index your entire drive and search very rapidly. Is there an ability to do that without having to point to a particular document, but rather just say, index my entire computer?
Well, I don't think we can do it right now, but I think that's a good idea. Daniel, do you want to comment on that?
Yes, thank you for your question. So we agree that this is something that would be very nice to have. Basically, we don't have this right now. What we have is documented database, which is, So we focused first on indexing like a Documentum repository and then large scale with a client-server architecture. But the way it's designed sort of opens the possibility later to sort of do it locally on your hard drive. So we have this in mind. It will take a little time, but eventually we will want to do that as well, yes.
Did you have some numbers, like what percentage of accuracy you got for certain test sets of documents, converting them to structures?
Yes, we do have, we run bench tests for our English name to structure. We also run some bench tests for our Chinese name to structure. For the English conversion, we actually run a bench test together with Linguimatics, and we look at not only the accuracies, how much information retrieved are relevant, and how relevant the information retrieved. So, in summary, the total score is 90%. We had joint presentation with Linguimatics. I can send you the presentation.